Welcome back to Pleopod, the show where we demystify the tech shaping our future. I'm Armin.
And I'm Maya. Today we've got a story that's got mathematicians buzzing and AI researchers feeling, well, a bit vindicated, maybe.
Exactly. We're talking about OpenAI's recent announcement that their AI has made a significant breakthrough on a math problem first posed in 1946. This isn't just about finding a new pattern. It's about creative reasoning.
The problem is called the planar unit distance problem. It sounds abstract, but it's about how you arrange points on a flat surface so that a certain number of them are exactly 1 unit apart. For almost 80 years, the prevailing wisdom, the intuition among mathematicians, was that the best way to maximize these unit distances was to arrange points in a square grid.
Right. Think of points on graph paper. The assumption was that the square grid was the most efficient layout, and for decades, no one could really disprove this. It's a foundational idea in discrete geometry.
But then, OpenAI's general-purpose reasoning model comes along. It wasn't specifically trained on this problem, or even on advanced mathematics proofs, but it autonomously produced a proof that disproves this long-standing conjecture. It found a whole new family of point arrangements that are, mathematically speaking, much better at creating unit distances than the square grids.
This is a crucial point, Maya. It didn't just synthesize existing knowledge or find a clever combination of known techniques. It seems to have generated novel mathematical insight. A group of top mathematicians, including figures like Tim Gowers, who was a Fields medalist, have verified the proof. And Gowers himself called it a milestone for AI in mathematics.
That's huge praise. It suggests that AI is moving beyond just being a powerful search engine or a synthesis tool. It's starting to show signs of autonomous, creative reasoning. The AI apparently used techniques from algebraic number theory, which wasn't necessarily expected for this kind of geometric problem.
Is fascinating because it shows the power of general-purpose AI. Instead of building a narrow AI for geometry, they used the model design for broad reasoning, and it ended up making a discovery in a specialized field.
So, has the planar unit distance problem been completely solved then?
Not entirely. The AI's proof overturned the assumption about square grids and found a better way to construct point sets. It showed that the growth rate of these unit distances is better than previously thought. Specifically, it found constructions that yield a polynomial improvement over the old grid-based upper bounds. However, the exact growth rate, the absolute optimal solution, is still an open question. So the problem is still partially unsolved, but this is a monumental step forward.
It's like the AI found a new, much wider path, but we're still figuring out exactly how far that path goes or where it perfectly ends.
Precisely. And what's also interesting is the implications for future scientific discovery. If an AI can independently challenge decades of mathematical intuition and generate proofs, what other scientific frontiers could it help us explore?
It really blurs the lines between human and machine creativity. It's not just about computation anymore. It's about genuine insight and discovery. This feels like a pivotal moment for AI's role in pure science.
Absolutely. It's a testament to the progress in general-purpose reasoning models. The idea that an AI could tackle and make novel contributions to a problem that has stumped human mathematicians for generations is pretty profound.
It makes you wonder what other complex problems AI might help us solve in the future, and what new avenues of inquiry it might open up for us all.
It certainly does. It's a fascinating glimpse into what's possible when we combine human curiosity with advanced artificial intelligence. Thanks for joining us on Pleopod.
It was great discussing this with you, Armand. See you next time.